Okay, so next one is power MOSFET. So power MOSFET, as we know that transistors have several drawbacks like the temperature dependence on collector current and other things. You generally don't use BJTs unless it is very much required. You go for MOSFETs. Okay, so power MOSFET is same as power BJT, except that the power delivered by the MOSFET is going to be in the order of amperes. So two commonly available N-channel power MOSFETs are displayed here, and the breakdown voltage, the drain current, and the power output and other parameters are tabulated here for your reference. You can see the 2N6757 is one model and 2N6792 is one more model. You can see the maximum applicable voltage VDS is 150 volts in the first case, and it is 400 volts in the second case. And the maximum drain current is going to be 8 amperes in the first case and 2 amperes in the second case. And the power dissipation is going to be 75 watts in the first case and 20 watts in the second case. You can see huge amount of power is output. It's coming out from your MOSFET. That is because the operating voltage VDS is also very high and the drain current ID is also in the range of amperes. Okay, so that is the reason why the power dissipation is very high, and this output power is required for us in many applications. So these two MOSFETs are available in the market, which are going to be called as power MOSFET. So power MOSFETs are different from BJT in terms of operating principles and performance. Yes, you know that BJT is a current control device, whereas MOSFET is a voltage control device, right? So the operating principles of power MOSFETs and power BJTs will be completely different. And power MOSFETs are comparatively superior to performance in when you compare that with your power BJTs. So you in the power MOSFETs you have faster switching time. So the device can switch from on state to off state in a very time. It will not take a longer amount of time. It can switch between the states very quickly. There is no second breakdown as you have in power BJT. The gain is very stable and the response time is also very good. So it will respond very fast over a wide temperature range. Since the temperature dependence on MOSFET is very, very less, we usually go for power MOSFET when you are having a requirement of high power applications. When you have a choice to go between BJT and MOSFET, you go for MOSFET because of all these reasons. The switching time is very fast. There is no second breakdown as you have in your BJT. The gain is very stable. You have a flat gain, constant gain, and MOSFETs will respond very quicker compared to your BJTs over a wide temperature range. So now we are going to see the drain current characteristics for the power MOSFET as we have seen for the power BJT. So you can see as the drain current is increased, the trans conductance is also increased, and you can see the temperature dependence. As the temperature is going to be decreased, the trans conductance is increasing. So it has a negative temperature coefficient because all the parameters will decrease when you increase in temperature. It's going to be the reverse. And you can see if you vary VGS, the drain current is increasing. And as the temperature is going to increase, the drain current is going to be even more increasing. So these are the two characteristics, trans conductance characteristics and the VGS versus ID characteristics for your power BJT. The T temperatures have been considered minus 55, 25 and 120 Celsius. So at these T temperatures, they have measured the values for drain current, trans conductance and VGS, and the graph is plotted, which shows that the temperature dependence is not a major problem in power MOSFET because the graphs are very close. And the difference in value is also very, very close, right? So the temperature dependence is also very, very less in case of power MOSFET. Okay. So MOSFET, you know, it has a very high input impedance, and you know in the gate terminal is open. The input is going to be gate, and the gate terminal is open, right? So it has a very high input impedance, and you know it is a voltage control device. Unlike BJT, MOSFET is a voltage control device, whereas BJT is a current control device. So the circuit required to drive the MOSFET is going to be very, very simple. So unlike BJT, the circuit is not going to be very, very complex. The circuit which is going to drive the MOSFET is going to be very, very simple. So even you see the gate current of 10 amperes can be driven by the gate of 10 amperes power MOSFET can may be driven by the output of a standard logic circuit. So simple circuits can easily drive your MOSFETs. And you know that all these category of FET, field effect transistors, they are all majority carrier devices, or I can say they are unipolar devices. Which increases the resistivity of the semiconductor. So it is clear that MOSFETs are more immune to thermal runaway effect and second breakdown as in BJT. So the temperature will have a serious effect on the mobility of the majority carriers. So if the majority carriers are likely to move very slower, then the current is also going to be reduced. Okay, so this drawback is there in MOSFET. So in BJT, we have the same effect, thermal runaway and second breakdown, but MOSFETs are more immune to these effects. The thermal runaway is not there in MOSFET. Second breakdown is not there in MOSFET, but temperature might play a small effect on the performance of your power MOSFET. That you have to understand. So you can see the from the graph what we have seen, the VGS at a high current level, when you are from the characteristics curves, the VGS at a high current level, the current actually decreases with increase in temperature. If you see the graph, so as the temperature is going to increase, the current is decreasing. So this is for minus 55. The last one is minus 55. The second one is 25. Third one is 125. So you can see as the temperature is increasing, the current is reducing because of reduction in mobility of your majority carriers. So compared to BJT, these power MOSFETs can handle not very high power. The power handling capability is very much limited when you compare your MOSFET with BJT. And the drawback is you can the disadvantage of this disadvantage is compensated by, you see, in BJTs we grow the structure in a vertically one, but in MOSFET you are going to have a planar structure. So if you change the planar structure to a vertical grown structure, you can improve the characteristics of MOSFET. See, usually MOSFET is grown in a planar way. Planar means everything is grown side by side. But if you change that to a vertical structure where you are going to grow the layers vertically one above the other, so this performance parameters of MOSFET can be improved by a larger extent. So power MOSFETs have different structures compared to the conventional MOSFETs. So by having a double diffused layer or a vertically diffused process, so such MOSFETs are called as VMOS and DMOS. So when the conventional fabrication process changed for power MOSFET, we have two prominently used process called as double diffused MOSFET. It is called as DMOS, and vertically diffused MOSFET. It is called as VMOS. So these two types of power MOSFETs, VMOS and DMOS, are very very popular because of, and they get the name because of the fabrication